I'm going to use a couple minutes of your time in this video to explain some of the physics that goes into making music, namely vibrations, resonance, wavelength, and frequency, and their relationship with each other. I could demonstrate by using a drum set, the instrument that I know best, but that would not be a convenient way to get my message across, so I will be using a guitar. When you pluck a string, it makes a sound. More specifically, the plucked string causes air molecules to push on one another, creating a wave of molecules called vibration. The pitch or note of the sound is determined by the vibration's frequency, or rate at which sound waves are being generated. Frequencies and wavelengths are inversely related. So the higher the frequency, the shorter the wavelength, and longer wavelengths correlate with lower frequencies, lower notes. For example, this has a longer wavelength than this. Now, the vibration will last as long as it has energy for, but once the vibration starts to taper down, the volume of the sound will actually fade away. However, if there is another body that can vibrate at the same frequency as the string, that body will resonate and play the same exact note. For example, the air molecules inside this hollow body of the guitar will resonate at the same frequency when I play a note. This multiplies the amplitude of the wavelengths and increases the volume of the note. The pitch or note can be affected by three things on a guitar, two of which are fixed. The first thing is this tuning mechanism, which affects the tension of the string. And the second thing is the weight of the string. Obviously, heavier things are harder to make vibrate than lighter things. The third factor that goes into changing the pitch is the one that we can control, and it's the length of the string. Changing the fret on a fretboard essentially takes the original end of the string and duplicates it on another point of the guitar, so that the distance from here to here is shortened from here to here. I'm going to show you something that will make visualizing this a lot easier. What you just saw on camera is a standing wave. I can reposition my fingers and pluck different strings to make the notes dance around each other. It represents something curious about the nature of sound waves as well. Say you are holding a rope on its end, and the other end is fixed to a wall. You move your hand rapidly, and a pulse will travel through the rope to the wall, which then bounces back from the wall. To generate more waves, simply keep moving your hand. And if you move your hand at the resonant frequency, the waves that move back and forth will cancel out and reinforce each other in such a way that the waves look like they are standing still. Increase the frequency by a factor of 2 and something interesting happens. The standing wave is cut in half, and two standing waves appear along with the standing wave, called overtones or harmonics. Sometimes it can be seen as one, sometimes as two. Increase the frequency again and again repeatedly to have 3 or more overtones. This is what's happening with the guitar. The rope is the string being struck, and the wall is the nut beneath the tuning mechanism. This reveals something exquisite about music, math, and the human experience. Not only can multiple frequencies of the same note be played at the same time, but also multiple frequencies of different notes can be played at the same time. You know what a note is. It's right here. You pair a note with another note, and it's called an interval. 3 notes together or more creates a chord. Chord structure in songs is what gives music life, and this is where music becomes math. In any given key, different chords are assigned number values. The specific patterns that these number values come together to make is what affects us emotionally as humans. For example, the pattern 1645 is a common theme in 80s rock music during the chorus that releases feel-good hormones in our bodies. I am not going to go in depth about the physiological effects that chord progressions have on us, but that's pretty amazing. In this minor breakdown of the physics of music, I hope I've been able to create a better understanding of what makes sound, and also how one can influence the nature of vibrations in order to create pieces of music and maybe promote artistry. Thank you.